number 29. Y equals 1/5 to the power of x. So we're going to type it into y equals in our calculator. Always use parentheses for fractions. We're going to look at the graph, and then we're going to go to the table of values to let us know what points we are going to plot on our graph. So it looks like from -1 to maybe 2 for the x values we can graph. So I'm going to make a table. And I'm going to plot those points on my graph. When it gets to the point 1, 0.2, 2, 0.04, it's going to be pretty hard to graph. Just do the best you can and make sure it's exponentially decreasing the whole time. But remember, it's not going to cross over that x-axis. And make sure to put arrows on the edges of your graph because it's continuous. We're going to do the similar thing for number 30. F of x equals 1/2 to the power of x. I'm going to take a look at the graph. And then I'm going to go to my table of values. So for this one, I'm going to start -3, 8, -2, 4, -1, 2, 0, 1, 1.5. Number 31. For each function, compare the table of values and their graphs. So what we're going to do is we're going to compare the table of values and their graphs. Now we know this is a linear function, this is a quadratic function, and this is an exponential growth function. So we're going to type these in, the y equals, in our calculator. We know for a linear function that the common difference is the same. So these are all going up by 5s for each y value as the x's increases. What I'm going to do is I'm going to put these functions in at the same time. And if you have a colored calculator, it's going to be easier for you to see the difference. So here's y1, which is our linear function, y2, which is our quadratic function, and y3, which is our exponential function. So we can compare all the values right here on our calculator. Which is a quadratic function? F of x equals x squared plus 4x minus 12. We also can look at the graphs. There was our line, our first function. There was our quadratic, our second function. And there's our exponential growth function, which is the third function that we type in. What key feature did you use to determine the type of the function? I knew that when the degree is 2, it is a quadratic function. Also, the table of values, when I go back to the table of values, I see that point of reflection. I see the symmetry in the table, so I know that that's my vertex. And then I can see in the parabola on the graph the symmetry going out from the y values. So also the table of values shows the vertex and the symmetry. Part B, which function is a linear function? And we said that that was our f of x equals 5x minus 4. That's our y equals mx plus b. What key feature did you use to determine this type of function? I knew that when a function is in the form y equals mx plus b, it is a line. Also, when we look at the table of values, we're going to say there is a common difference in the y values. Because as you can see, they're going up by 5 each time. So that means that it's linear when we look at our table. Number 32. For each function, compare the table of values and their graphs. So very similar to what we just did. So what I'm going to do is I'm going to look at this. I know that this is an exponential decay. I know that this is a linear function. And I know that this is a quadratic function. So I'm going to type these into my calculator just like I did before for the last problem. So the first one is my exponential decay. My second one is my line. And my third one is my quadratic. So there's my first function. There's my second function. And that's my third function, my quadratic function. So which function is a linear function? F of x equals negative 3x minus 7, which was our second function that we typed in. So if we look at our table of values, if we look at our table for our second function, which was our line, we see that the common difference is the same. This time it's going down by 3 each time we go up a value for the x's. So we're going to say something very similar to what we just did above. I knew that when a function is in the form y equals mx plus b, it is a line. Also, when I looked at the table of values, there is a common difference in the y values. Which function is exponential? That was our first function that we typed in, which was f of x equals 4 times 0.5 to the x. What key feature did you use to determine this type of function? Well, let's take a look at our table of values. When we look at our table of values, we see that they're decreasing by a common ratio. In other words, you are multiplying by a fraction. And each time we're increasing for the x's, our y values are going down by 1/2. So we're multiplying by 1/2. And when it has that common ratio, that's when it's exponential. So I know that when I look at the table of values, there is a common ratio. y values are being multiplied by 1/2 for every increase.